Hello everyone and welcome back from our snow jam, snowpocalypse, whatever you want to call it. But this video is Friday night's homework to watch and learn about Descartes' rule of signs. This is the last topic in lesson 4.4, section 4.4 that we'll do before our quiz next week. And shortly after that we'll actually have a test on sections 1 through 5. Descartes' rule of signs is kind of a way for us to narrow down those possible rational roots that we made a list of with the rational root theorem and narrow it down a bit further so you don't have to plug in quite as many numbers. And what Descartes' rule of signs is that there are two parts. If we want to figure out the number of positive real zeros, then we want to count the sign changes in f of x. But it's not so simple as just counting those. We have to think about subtracting multiples of 2. So for example, if our function was f of x equals 6x to the 5th minus x to the 4th minus x squared plus 3, and we want to figure out how many positive real zeros we might have. Now notice that this is real zeros. It's not just rational. This includes the stuff with the square roots. It doesn't include the imaginary ones. But let's count the sign changes. So right here, this is positive. This changes to negative. That's one sign change. But then here from negative x to the 4th to negative x squared, that does not change signs. From negative x squared to 3, this does change signs. So total, we have 2 sign changes in f of x. What that means is that there could be 2 real zeros, sorry, I should say 2 positive real zeros. But we don't know that there's necessarily 2, so that's where this minus multiples of 2's comes in. So think about what's 2 minus 2. Well, 2 minus 2 is 0, so there could actually be 0 positive real roots. What that means is there might be all imaginary roots, or all of the roots might be negative if we have no positive real roots, or zeros. Same thing. So you guys know that zeros and roots are the same. So there are either 2 or 0 positive real zeros, or real roots. I'll probably say roots in the future. They mean the same thing. Now, to find the number of negative zeros, we're not going to look at f of x anymore. We're actually going to look at f of negative x. And you might be wondering, well, what does that mean? It means exactly that. See how the negative x is in the parentheses? We're going to plug in negative x up here for x and see what happens to our function. So now I'm going to have 6, but instead of x, I'm going to write in negative x. I'll actually write the skeleton of the function first so I don't keep changing colors. 6x to the 5th, but now I'm going to put negative x in there. Minus, I'm going to put negative x in for x to the 4th. Minus, I'm going to put negative x in for that x squared. Plus 3. And here's where you have to be very careful with your powers. It's a very common mistake for students right here to see negative, negative, well that makes positive. But you're forgetting order of operations if you do that. Order of operations says you must do exponents first. So you must do negative x to the 5th. Well, a negative number to an odd power is going to still be negative. So negative number to an odd power is still going to be negative. So this ends up being negative 6x to the 5th. But now let's think about negative x to the 4th. Negative x to the 4th, a negative number to a even power, is going to be positive. Just like negative 2 squared is positive 4. Negative 2 to the 4th would be positive 16. So this ends up being positive x to the 4th, but we're still subtracting. So it's minus x to the 4th, not plus as you might have thought. Here, A negative x, again, will become positive with the square, but we're subtracting a positive, and then the plus 3 at the end. So now let's count our sign changes. No sign change, no sign change, one sign change. Because there's one sign change here, we have one negative real root. Now, if we were actually to find the root, if we know that there's only one negative one, I'm going to look for that one first. So when we make our list of all the possible roots, I would plug in all the negative numbers to figure that one. Because once I find one, I'm done. And I'll actually do an entire problem all the way through. So now, let's do another example. Again, remember, actually one question you might have is, why didn't I subtract the multiple of 2 here? Well, if I subtract 2 from 1, I get negative 1. Well, I can't have a negative number of roots. And so we don't count this as 1 or 0. It's just 1. There must be 1. Okay, so now let's do another one where we actually find all of the roots and follow through with that. So my function is going to be f of x equals 2x to the 4th minus x cubed minus 2x squared plus 5x plus 1. If this is my function, I'm going to first list the possible rational roots. And it's doing the p over q, I get 1 over 1, 1 over 2. Plus or minus 1, plus or minus 1/2. Those are the only possible rational roots. Well, now let's move on to Descartes' rule of signs. Let's look for the positive real zeros, or roots. Count the sign changes. There are 1, no more there, 2 sign changes. So because there are 2 sign changes in f of x, that means that there are 2, and don't forget to subtract multiples of 2, or 0 positive real roots. If I want to look at my negative real roots, I have to plug in negative x in for x. So I'm going to get 2 negative x to the 4th minus negative x cubed minus 2 negative x squared plus 5 times negative x plus 1. A negative number to an even power is positive. A negative number to an odd power is negative, but negative times a negative is positive. So if you want to prove that, you're doing the x cubed part first. Negative cubed is negative, minus a negative is positive. Negative squared is positive, but minus a positive is negative. Positive negative is negative. And now count the sign changes. Well, there's 1 sign change here, another sign change here. So 2 sign changes in f of negative x means that there are 2 or 0 negative real roots. Well, there are a few ways that you can find them. One of them is to plug in these numbers and see if any of them work, as you guys know. Another is to look at the graph. I'm actually going to talk about the graph in this case. If you look at the graph, which I can't show you here, but if you take this f of x and plug it into y1 and graph it, you should see that there are no x-intercepts. Well, if there are no x-intercepts, you should know that that means there are no real roots. So in this case, it's actually 0 negative real roots and 0 positive real roots, because there are none whatsoever. So at this point, we've learned how to find the number of possible positive real roots and the number of possible negative real roots. If you want to actually find the roots, you can do synthetic division, or you can look at the graph. So what I want you guys to do for homework is on page 233, do number 7 and 8. And on the worksheet that I gave you on Tuesday, when the sub was here, do those last two problems that I told you not to do. So number 9 and 10. Those 4 problems, we'll talk about them on Monday. And remember that we have a quiz on section 4.3 and 4.4 on Wednesday or Thursday, depending on when I see you. Have a great weekend, and I will see you on Monday.